So next electrical gate 22 paper problem number 21 from analog electronics. So that's very simple, 1 mark. For the circuit shown below with the ideal diodes, the output will be. Given diodes are ideal, that means if it is in forward bias, an ideal diode in forward bias will act as a closed switch between the terminals anode and cathode. Doesn't have any potential VD that is equal to 0, but can have any current ID. Okay, if it is in reverse bias, it is simply a open circuit. Okay, reverse potential exists between anode and cathode, but the current is equal to 0 through the terminals anode and cathode. Yes, that's a basic of an ideal diode. We have two ideal diodes. So we have excitation, assuming we are doing the analysis in the positive of cycle. Okay, so in the positive of cycle, that is 0 to pi. Okay, so taking this as a reference, so this will be V in. So this is V in, and that is positive throughout the positive of cycle. Let me set the problem at theta equal to pi by 2. At theta equal to pi by 2, the V in will be equal to what? Its peak Vp. So I'm setting Vp. So then this is Vp and this is 0. Therefore, definitely, even if the two diodes are off, okay, if the two diodes are off, then otherwise you assume diode is in forward bias, D1 in forward bias, because it is sensing higher potential at the anode. So then the current is going to exist this way, and this current is 0. Therefore, the current flow will be this way, and then this direction of current will be supported by diode D2 as well. So therefore, D1 always remains in on condition or in forward bias throughout the positive of cycle. D2 also remains in on condition and forward bias. Okay, so both D1 and D2 are in on condition, but they take nothing from the supply voltage V in. Therefore, shortly I can say whatever the voltage we have at the input will be available at the output. V out is equal to V in. Okay. Reason this is a short, this is also a short, so V out will be equal to V in throughout the positive of cycle. So during positive of cycles of V in, V naught follows V in. That is V out follows V in. Shortly, I'm writing this way. During negative off cycle, so the V in is going to become negative. D1 will become reverse bias. Therefore, the reverse current won't exist. Therefore, simply V naught is equal to 0. So the point is this: V out is equal to V in only during positive off cycle. Then how to say this? Which option is saying this? V out is equal to V in when V in is greater than 0. It seems to be okay. V out is equal to V in for V in less than 0. No, V out is equal to minus V in for. Yes, let me check the sign. So nothing. No, this is not the right call. V out is equal to minus V in. V out is equal to minus V in. Okay, so for V in less than 0, no. Okay, yes. So the best choice is option A only. So that's a simple problem looking like a off wave rectifier. Okay, so producing only positive off cycles in the output and not giving any output during negative off cycles. Okay. Yes, we'll update you with the next problem soon.